Okay, we're going to work on solving X-Intercepts. You see a lot of times they're called roots, okay, X-Intercepts from Vertex Form. So this is in the Vertex Form of a trinomial, okay? This is a quadratic function. And an X-Intercept is when we're on a graph. Okay, so say we're to graph this. Your X-Intercepts are when your Y value is at 0. These are where X-Intercepts are. In this case, it probably does something like this. Y is equal to 0 at this point. So with that in mind, we're going to set Y equal to 0, and we're going to solve for X. And so it's equal to 1x plus 1 squared minus 16. Now you might think, why did he write the number 1 in here? Even in the question, I drew it red here because it wasn't included. I just want to show you this extra step because if this is the A value in Vertex Form, if it was a different number, you'd have to do it. You'll see how it's irrelevant with the 1, but I want to show you the process. Because we only have one variable, this is great. I don't have to do any kind of factoring. I just kind of have to know bedmass and isolate properly. So because I'm trying to isolate for x, okay, we kind of think of it like reverse bedmass. I'm going to deal with the subtraction first. When I bring over negative 16 to the other side, what does that become?
Positive.
Yeah, so 16 is equal to 1x plus 1 squared. Great. Again, still reverse bedmass, so I got to move the 1 over. And because the 1 is multiplied by, when I bring it to the other side, it becomes divided. Does that do anything for our number here?
No.
It doesn't, but I just want you to keep that in mind, okay? So it's still 16. Now think of it like x plus 1 squared. Great. Next, we need to move over our root before we can deal with anything in the brackets. What's the opposite of a power of 2? What function would you use to move something power of 2 over? Do you remember? No? Okay. The opposite of it is a square root. So I would square root both sides, or like we've been doing in the past, when you move it over, think of it like you need to square root. So we square root 16, and we get the number 4. Right? 4 is equal to x plus 1. Now there's an issue with this. Technically, root 16 has 2 answers. There's positive 4, and there's negative 4. 2 answers to this. So in other words, there's 2 answers here. So when you think back to factoring, or using specifically the quadratic formula, if you know it, you remember how the quadratic formula splits at one point? This would be the point where it's split. We're just using a different style. Because it would split, I want you to think of this now. Positive 4 equals x plus 1, or negative 4 equals x plus 1. Okay? Still solve for x. When I move 1 over, it becomes subtract 1, so x is 3. And when I move 1 over, it becomes subtract 1, so we get negative 5. Is that okay?
Mm-hmm.
The integer part was okay?
Yeah.
So our two x-intercepts are 3 and negative 5, which makes a lot of sense. 3, negative 5, because it's a parabola, there's going to be 2 x-intercepts. So that splitting is really important. If I had just done positive 4, we would have only had a value of 3, and then you would have had to be like, well, I guess it must do something like this, right? But looking at this is in vertex form, positive 1, so it's over 1. Positive, it's negative 1, so it's over here, and down 16. The vertex is down here, so if it's a quadratic, it has to be going up, right? So it had to have 2 x-intercepts. So that would have given us a problem if we didn't do a plus and a minus. So being aware of what other information, because this gives us our vertex, we can plot our vertex. Now this isn't drawn to scale, because the 3 would be closer and the 5 would be farther. And the vertex would be here. This is a much better, this blue version here, scale than what we had originally drawn, okay? Does that make sense, that idea?
Yeah.
Okay.